Hello, my name is Obi Anunachi. I'm presenting this week's Data Engineers Lunch. We're on Data Engineers Lunch number 17. Um, we started this initiative last year in order to get data engineering community together. So Data Engineers Lunch 17 is on NoSQL Datastore types. It's sort of part three. So as part of our exploration of the data engineering roadmap, uh, my audio coming through fine, by the way?
Yep.
Yeah, you're good.
Okay, good. As part of the exploration of data engineering roadmap, we've had a couple previous ones on NoSQL databases. Um, the first one was just an introduction to them. The second was about acid versus base. So sort of the promises that NoSQL databases make versus the one that SQL databases make, and then the cap theorem. Um, and this one is about sort of the underlying data types that they're actually storing. Um, So currently, Rahul Singh is the only organizer for these data engineers lunches. He's looking for co-organizers if you are interested. A co-organizer would help get speakers by reaching out to people in the community um, and ask them to speak here at these data engineers lunches if they're interested. If you're interested, contact Rahul at Anant.us. Um, so this data engineers lunch community is part of a larger community called Data Community DC. It's made up of a bunch of different groups and diverse initiatives. Let's see. Yes, it's made up of a bunch of different meetups and communities, including Full Stack DC, etc. Sorry, do you mind muting real quick? All right, thank you. Um, so generally here we cover anything related to data engineering, data science, and anything that you might need to know to become a good data engineer. If there's anyone new, you can introduce yourselves, say what brought you here today, and what you hope to get out of this series of talks. Are there any new people?
Is anyone new to this call?
I think it's just Javid.
Yeah, this is Javid, just me. I just joined today.
Yeah, nice to meet you.
Yeah, thanks.
Okay. So group rules, if you have a question during the presentation, you can ask it. Be polite and courteous to others and share what you know with us specifically during this presentation. We're basically just going to be talking for a little bit. Uh, but if you know something that I forgot to include, feel free to just speak up.
Sure.
And I would say, Obi, it's easier to put it in as a comment if you can when it's during the presentation. And then when Obi calls on you or something to talk, then you can talk because it'll make the flow better.
Okay.
Yeah. Okay. On our company now, we work on technologies related to global real-time data platforms, generally Spark, Cassandra, and Kafka. So data engineering is part of what we do. DataStax is a partner and a sponsor, as is GWU, especially when we're having in-person events. We also have some local and institutional partners in DC and Chicago areas. So does anyone have announcements looking for a job or hiring, meetups coming up soon, um, anything else happening soon?
Well, shameless plug, a not corporation is hiring data engineers, particularly around DataStax and Cassandra. But if anybody else is hiring or there's a hackathon or you have a meetup that you like to mention, you can mention right now.
All right, moving on. So these data engineers lunch and our Cassandra lunch happen often. We have guest speakers sort of lined up for late April. Um, Yep. Okay. Moving on to the actual presentation today. We're basically just going over some notes on NoSQL data store types. So talking about NoSQL databases just means not only SQL, so they can have extensions or subsets of SQL functionality. And they have different advantages and disadvantages over SQL. But what we're going to talk about today is sort of how they differ from each other in one particular way. So there are a lot of ways in which NoSQL databases can differ from each other. The way the scalability works, whether they're open or closed source, what they can do out of that SQL superset, what query language additions they have. Some of these languages, some of these databases can be queried via MapReduce, some of them via REST API, some of them via query language that's like SQL. And then what solutions they come up for in regards to the CAP theorem. We talked about that a little bit a couple weeks back when we were last talking about NoSQL databases, but CAP is for consistency, availability, and partition tolerance. And the idea there being that you can have at most two. So which two they choose and how they choose to implement the solutions, or whether you can potentially configure it to particular solutions, is something that makes NoSQL databases different from each other. But the thing that we're going to talk about today is data store types. So obviously, like a SQL database stores things in a table. NoSQL databases can be like that, but they can also be slightly different. The most basic storage mechanism is a key value store. You have a key and you have your data, which is the value. It's associated via a hash table. Some of the databases implement caching so that you get quicker reads. You don't have to go and search them up fresh each time. And inside of that key value store, your data is stored in string format, maybe JSON format, and potentially just a binary blob. Blob is for, I think, binary large object, but it just means you have a bunch of binary data. So examples include DynamoDB, which will actually come up again because it's sort of mixed model database, as is Cosmos. Redis is not, it's a pure key value store. Use cases for key value store databases or shopping carts and user profiles, simple things that are associated with each other, essentially. So our second type is document stores. They are sort of still based in a key value model. So individual documents will have a key and the actual document will be the value. But documents can contain things like XML, JSON, BSON, which is a binary translation of JSON. I don't think the acronym makes much sense because if you just replace the J for JavaScript with B for binary, you get binary script object notation, which is not what's going on there. So examples of document storage databases are MongoDB, CouchDB, and again, you see DynamoDB and CosmosDB because you can have them running in a mode where they're doing document storage rather than key value storage. So the advantages of document storage are your schema flexibility. Essentially, you can have whatever you want inside of the document. And then those documents can store data in forms that are more useful for applications. So theoretically, if you were using a normal SQL database to fill out a web page, all of the different data that goes in there in different sections would have to be to recall correctly, that BSON takes more disk space but has faster access speeds than JSON. I think that is correct. I'm not entirely sure that it would take more disk space either. Yeah, anyway, so what I was saying about for applications, if you have data stored in a number of different tables, you have to go access from each one. But in a document storage database, you can combine all of that into a single document. So you get out subsections of that document to build the individual sections of your web page. But you just read the document once and get all the data you need rather than reading and combining from different tables like you might need to in an SQL database. So use cases are e-commerce, trading platforms, and mobile app development. Our third type is the column store or column family, or there are a number of different ways to say this. So your data is stored in column families, which are a selection of columns from your table. And then inside those columns, you get tuples of names and values for individual rows and individual like data points. And essentially the column families are similarly typed generally so that they compress better. And examples of column stored databases are Cassandra, HBase, and Google Bigtable. I believe they were originally based off the Google Bigtable paper, of which Google Bigtable is an implementation. Advantages, you get a quick query speed, especially for subsections of rows. So if you need to pull out 2 or 3 individual columns, you can do that much quicker in a column family database than you might need to by pulling out the entire row out of a more traditional database and then cutting off the data that you don't want. And then it's also very quick for aggregation of individual columns. So doing things like sums and averages on your numerical columns can be done quickly in a column family database. Use cases for this include analytics, data warehouses, business intelligence tools, and customer resource management systems. And then lastly, your graph stores. Data is stored in a directed graph, nodes which contain properties, and edges which contain properties. The properties generally will contain your actual data, but they're just organized by the nodes and edges. Nodes being entities and edges being relationships between those entities. Examples include InfoGrid, Infinite Graph, Neo4j. Underneath the graph layer, graph databases could potentially store data in sort of key value format. I vaguely remember like DSE graph eventually like essentially stores data inside Cassandra anyway. So you still get the same directed graph capabilities, but your data is stored in the end in that column family format. So your advantages is you can model relationship complexity better than just normal SQL tables. And it's very good at modeling networks. So it's used for things like social networks and knowledge graphs. And that is what it's good for. So that is about all I have. If there are any questions or anyone else knows things about NoSQL databases or data storage types that they want to talk about, feel free now.
This is very interesting. Thank you. And can you talk a little, like you've discussed the I think advantages for most of these non-relational data store types. That said, you can basically do just about anything using a standard relational database. The question then is performance, especially for graph stores. At what point would you suggest switching to from something like Postgres to something like Neo4j?
I'm not entirely sure I have the capability to answer that. Is there anyone on right now who has a better idea of when you would switch?
What I would think of is all about when it comes to performance, right? There's a point in time when your application gets to a certain level that has, it grows from thousands to millions of requests, right? If you have your application, let's say mobile app that's distributed across multiple regions over the world, right? For that flexibility, for that throughput and everything to make sure, the responses, the performance are good for, the users using the application, right? At that process, definitely you want to switch from using Postgres to a kind of NoSQL database because that's easier for you to utilize better. That's what I think.
So make the change when the performance starts being required for the application. That makes sense.
Yeah, because after a while, you definitely have to study your kind of requests you're getting from the application, right? How many users you're having and all that. So based on your analysis on all that, that gets to that level where your performance starts to go down, and why you request or users are increasing, right? At that moment, you probably want to switch. Yeah.
Right. And there are certainly some queries that are very complicated to write in regular SQL, but work very well in a graph database, both for performance and actually just writing the queries themselves. So it's like another good reason. Yeah.
Yeah, definitely. Because sometimes the query has to be, they are really expensive and powerful, and it's gonna take a lot of power on the machine. So
Hmm. And just a lot of time to write it and edit or proof the query itself.
yeah,
Which unless you have really big data, the time to write the query, it was probably going to be more expensive than the machines to run it.
hmm all these data stores, they all have limits and advantages and disadvantages. So you just have to use things based on kind of resources, kind of level you have based on whatever you're doing. So they
Uh,
have their own use cases. Yeah, definitely.
We also have a comment here about, okay, first one, for transaction data like banking is risky to move to NoSQL DB without ACID without seriously compromising data integrity. Um, yeah, so there's sort of that ACID versus base stuff we talked about before. That in certain use cases you need some serious like security, consistency, like assurances. Um, and in those use cases, you generally do one want to use something like Cassandra that only has eventual consistency. Um, you would need something with actual ACID assurances. So you probably stick to SQL. Uh, and another comment about interesting thing I've noticed with MongoDB in my specific use case, mining Twitter, is the huge amount of compression I get. My database is around 400 plus GB, but the required disk space is around 100 GB or less. MongoDB has added some level of ACID compliance in their new version. Yes, so there are in the NoSQL world some sort of application level things you can do to get closer to ACID, like compliance. Um, I remember one of the things we talked about was, I think it was Yugabyte, was complaining about the lack of actual like consistency in Cassandra, and that's what their product was meant to cover for. Um, and in terms of compression, like I mentioned a little bit about how column families are good for compression, because similar data is stored together, so you get the compression on that level. Um, but yeah, no NoSQL databases can help with that.
So the question that I'll ask about that to the group is, for an application where you want both document storage as well as proper transactions, would most people think it'd be best to just use a single database like MongoDB and rely on the ACID transactions there? Or would it make sense to architect that as one database for the transactions and another one a separate database for the document store, and then have the application use both? What are people's thoughts on that architecture?
I can comment on this a little bit. Hello, first of all, can you hear me?
Yes.
I'm currently working on a project that is using 3 different databases, and this is very common. It is called Polyglot Persistence. Just like you have polyglot programming, where you can choose any language you know that suits your team or your company. Same way you choose different databases for your applications and for different requirements in your application. So I have an application that's using Dynamo, it's using MySQL, and it's using Elasticsearch. And of course, MySQL is used for transactions. It just happens to be also the canonical database of that project, because it started 7 years ago and everything was stored in MySQL only. But in time, it evolved, and we added Dynamo for doing lookups for certain things. And then later we needed free text search, and we added Elasticsearch in the middle.
Well, that's quite interesting, and sounds like an effective architecture. And I saw that there was a comment saying that separate databases would make sense, but it depends a lot on the skill sets available. That's also an interesting question of, do we choose the technologies for a project because we're familiar with them, or do we learn to use technologies that would be a better solution?
That's a very good question. And by the way, I read something in a book. I think the book is called 70 something skills for an architect or something. And there is a chapter talking about basically an advice for architects. Do not use a technology just because it looks nice on your resume. Think about the product. Think about what you're building, about your application. What does your application need? That's the approach. You don't have to think about your resume. It's nice if you can achieve that thing, but it's not about your resume. It is about the performance of your application and what the company is doing, to support the company's business.
Yeah, also to add to that, right? Sometimes company have certain skill set, right, in their, in their environment, and they decided to use certain tools maybe because they're used to that tool. But at a certain level, if the company feel certain things are required, important for the company to move forward, definitely. That means they have to allocate time for training and get people to utilize that new technology. So sometimes it requires one of the workers, right, to push the company enough to that level to understand, like, hey, this technology is better to be included into our tech stack, and we would like to get people to get trained and upgrade themselves in this technology so we can implement it, in our process. So it can come in both ways. Sometimes some companies don't think that way, and sometimes somebody needs to push it to let them see why it is important. So definitely, if it's required, you need to collaborate and implement whatever it is. So if you're like sticking to just using transactional Postgres or MySQL, and you realize, okay, for this application to really do well, to handle certain transactions, certain things, all right, we require a document DB or something, like we need to get, like, we implement that, So and the application, we have to adjust to it to make sure the architecture works fine overall with the application. So that's what I feel.
Yeah, that's a very, very interesting point.
What else are we talking today? Is everything about NoSQL?
If you have NoSQL related like topics to bring up, feel free to. Just when we're finished talking about stuff today, we'll just close off the meeting. So.
Yeah, we can wrap up like the presentation aspect of it and then open it up for community discussion for the rest of the hour.
Would you like me to stop the recording?
Yep, you can go ahead.